since I'm recording. So today we're gonna talk about the fundamental of our mass spectrums and its applications. My name is Ivan. So today's agenda, as I was mentioned earlier, there's 2025 process monitor focus segments. That's where we believe there's a lot of emergent opportunities or emergent markets that we're able to capture using our process monitoring solutions. Second, I'm going to cover the principle, the concept of how the mass spectrums, the MS, is able to do the monitorings or samplings. Rest of it, just the detail of each sections. And last but not least, the most important part is the key away process mass spectrum applications. That's where I want you guys to start looking out some of the industry or key places that has those emerging markets that we're able to capture and also sell our turnkey solutions. So for our EPM monitoring solutions, that's the acronym, the short terms. The long term is called environmental process monitoring. So that means we do have two sections of monitoring solutions. One for the environmental monitoring, second one is for the process monitoring. For environmental monitoring, we're focusing on gas particulate matters. So that's where we work closely with the government agency, EPA, MOE, Minister of Environment, or some other university that are interested in monitoring pollutions, PM 2.5, PM 10, NOx, SOx. Those are for the environmental monitorings. But at the meantime, those applications can apply onto ambient air monitorings and also source monitorings. That's where we start talking to a lot of industry, such as power plants, coal fire plants, petroleums, refineries, or other heavy industry that emit a lot of pollutants. They can use our EM solution to monitor their emissions. Last, this is the section we want to cover today. It's called process monitoring. So process monitoring is the solution that where we help the customers to optimize or to have a better monitoring of their product productions. So sometimes when they need to mix one compounds with another compounds, they need to know what's the percentage, what are the concentration they need to mix together. So we have this process monitoring solutions that are able to help the customer to monitor their stream, their samples to have a better mixtures or better yield, like better productions. Also, we can monitor their gases they try to infuse into their products, or when they produce product, there's some gases emitted out. We can do all those continuous monitorings for better process monitorings. So for some key segments that we believe in 2025 will have a really high growth, such as specialty gas that was in semiconductor industries, industries such as biotechnologies. They do a lot of fermentations. They produce biofuel, biofood, biopharma that's including insulins, vaccines, or other biopharmaceutical products that was, using bacteria, algae to grow their products. And then we measure their outgas or maybe some gases they need to feed the algae, feed the bacteria. So in here, the application is called fermentation monitorings. Okay. Second, emerging markets, we believe we're going to see a lot. It's the clean energies. That's where we involve a lot of green energy productions. A lot of time people are talking about we're using hydrogens to produce electricities, hydrogen to become our next fuel instead of batteries. So we do see a lot of petrochemical industries. They are byproduct of hydrogens. They want to purify, make this hydrogen into a hydrogen fuel cell or hydrogen fuel to generate power, to generate electricities. Another one, I believe you guys already had a really successful cases. That's a syngas. syngas is where it's called synthetic gases. So we mix with one gases to produce different gases. One of the most emerging markets in Vietnam, we believe, is ammonia process, where we produce fertilizations. We produce ammonias. So that's something we believe there's a lot of emerging markets in this region, typically in Vietnam. Another one is called carbon capture utilities and storage, CCUS. Since a lot of people are talking about net zero, so that means we're trying to reduce our carbon footprint. So there's a lot of application or markets that we're trying to capture CO2 in the atmosphere or in the process gas. We're trying to capture all of the CO2, and then we store it into a gas tank, and then put it into a underground cave or somewhere that we give it another value to sell this CO2, so we can reduce our carbon footprints for general industries, such as refineries or petrochemical industry. So on our right hand side here, that's where our solution is able to fulfill those applications and then to sell it in these markets. So this is something we believe we'll see this high trend or high growth in this particular markets. Okay. So one thing I want to point out is the marketing highlights. So I'm sure you guys are now pretty aware of our products. If you go to our Thermo Fisher pages here, type in the solutions. If you scroll down, you'll see our application note. That's where most of our mature applications or mature um, implementation that is on the industry. So let's say I'm looking for something more like flare gas monitoring. We do have an application note using this mass spectrons to do monitoring. So all this application notes will be really useful as a salesperson to talk to your customers. So as you can see, we have a really mature application that is in the using this instruments. So all of these instruments you found, you can come here and type your product names, or sometimes you can look into the applications that you're interested in, or some segments or industries markets that you hear from your customers and you believe we have a solution. You can come here and then check it out. Okay. Seconds. Okay. So in here, I kind of highlight something that EPM products we believe with matures, and then we're able to capture a lot of opportunities. As you can see here, syngas, biofuel, fermentation, etc. And then also carbon capture. So you can go to the websites and found this on the websites. We also provide webinars to you and also to the customers. So if your customers are interested in our products or in our solutions, you can give them the link and also webinars. That's where the customer can learn more on the application and learn more about our products. Okay, so today's topic, I'm gonna cover our Prima Pro Sentinel Pro. It's called Process Mass Spectrons for Gas Analysis. So for our solutions, we tend to build four continuous monitoring applications. That means we are using less maintenance, automations, calibrations. Those analyzers can be extremely rugged, reliable, and then breakdowns events are really, really rare. So those mass spectrum analyzers are installed at the industrial plants. And then we do have automatic samples. And in here, it's a fast precision measurements for multi-components on multiple sample string. As you can see here, we're able to link up to several different gas stream or pipe to do a measurement sequentially. So we do have two products. One is called Prima, one is called Sentinels. For Prima, that was tend to focus more on the continuous monitoring on the process end. For Sentinels, um, same technology, but we are placing the Sentinels at the industrial site to do environmental monitoring for occupational health safeties. Okay. On your left-hand side here, it's a Sentinels. Middle is a Prima Pro and Prima EX Pro EX. And also we do have a benchtop mass spectrons that is for small scales in the lab, or we can put it on the bench. All of these solutions using the same concept and same technology. It's called mass spectrons. As you can see here, the principle of the mass how the mass spectrum works, it contain it contain there are six main parts for the mass spectrons. One is for the sample strings that goes in. We need to do a sample reduction because mass spectrons are under operating into a vacuum systems. So all of these gases coming in is at the atmosphere pressures. And so of course we need to do a reductions to make sure the gas stream can able to fulfill into the mass spectrum conditions, which is under vacuums. And secondly, we do have an ion source that able to break down our samples into different ions and also fragments. And then in here we have a mass filters. Imagine there's a filters that able to help us to um, identify different fragments or ions. And then last, we have a detectors. That's where we receive the signals and we can do a quantitations on our sample streams. So back to our the first step. So when the sample goes in, it has to go through a microcapillaries. That's where we reduce our sample size, reduce our sample vacuums. This is the sample. This is the graph for our sample inlets and a vacuum system of our Prima Pro. In the case that we do have it's called rapid multi-sample string that we're able to link up to different sample string. We take the process CS from the select sample strings into our iron source in here. The pressure was reduced to 1 million bar. So it's all done through automatically. And then here, in case of course we need to further reduce into vacuums. So here we have a molecular leak that allowed trace amount of gases into our system to be ionized. Rest of the gas will be sucked into this rough vacuums. So some of the gas will bypass into our rough vacuums. Rest of the sample string will go into this ion source and mass spectrons, and everything will be vacuum under our turbo pump. We do have a vacuum gauge in here that is automatically feed information to our system, say if the whole mast is under vacuumed. In here, this is our rapid multi-stream sampler RMS operations. Typically, the flow is about 500 milliliter per minute. For Sentinels, that's about 5 liter per minute. We are able to link up to 30 or 64 sample port. That means we're able to constantly monitoring samplings in sequence at 30 different sites of 64. Of course, we can have another dual RMS systems. That means we can double our sampling streams. Remember I was mentioned earlier, we do have a small model. It's called Prima BT. That is for Prima BTs, they have a similar multi-sample string, but much smaller. That they can the Prima BT has a 16 sample probes features. So this is the side view of our RMS. As you can see here, we have a rotors that we able to like a clock. We were able to point at different ports. So with the sample string can go into our systems. All of this, all of this RMS port are constantly flowing the air. So that means we are always getting the freshest air out of the sample strings. Our CO is good for about 10 million times of operation. So that means imagine this arm is kind of, we can do about 10 million times of moving. We're able to do a switching very quick. Every 10 seconds, we can do a really quick switching on port 1 to port 2 to port 3s. So of course, these are built to be really robust. Of course, we try to make our lifetimes and also much longer, and also to have a less maintenance service onto those moving parts. The RMS itself can heat up to 120 degrees Celsius to avoid any condensations from the gas streams. Of course, we don't want to introduce any water or any condensation into our instruments. So those parts were heated so to prevent any water to condense on those metal parts. So about these further reduction of the pressures, we use this called microcapillaries. Those microcapillaries are tight temperature controls. It has a really quick, rapid response, and also we do have special treatments on this microcapillaries. So a lot of like a polar molecular, like really sticky molecular, such as ammonias. We are able to let this small amount of compounds go through without any blockage. So the final pressures was provided. Sorry, the final pressure reduction is provided by a release a CO drill leak element. It's right here, as you can see. So this is only for Prima Pro. If we are monitoring using Sentinel Pro to do the environmental monitorings, this pressure reduction features will set differently. The whole process is just we trying to reduce the pressures, so the gas, your sample gas, will go into a vacuum phase to we are able to do the monitorings. Okay, so this is the graph for the Sentinel probe. They are just using different mechanisms to further reduce the pressures. As you can see, this is a membrane inlet. So this allowed our volatile compounds, VOC, or other compound of interest to pass through and to be concentrated in order to measure trace level at ppb or even lower concentrations. So as you can see here, this is ideal for concentration between ppb and ppm. So this is suitable for workplace safety monitoring. So after the gas stream go through pressure reductions, go through our microcapillaries. Right now we want to give energies. We try to give the energies to our sample gas to make it charge and also break into fragments. The main type of the source I use for process mass spectrum monitoring is called electron impact iron source, where where there's a where there's a thermal filament that is heat up over 1000 degrees Celsius and give out electrons here, and then accelerate it and to hit our sample gas, to collide with the sample gas to break into fragments and also ionized. Once the ionized fragments, our sample gases will go through our processing. Will go through our next step, which is the mass spectrons, where the filters we filter out the sample. In this case, the Prima Pro and Sentinels are there's a magnet sections that will give a different magnetic fields. The magnetic fields will affect on our ions, and then to have a different trajectories. Later, we do have a detectors here that we're able to detect what other compound goes in, what other concentrations, and then we use the computer to detect the signals to know what are the concentration of that particular compounds or particular fragments. This can be done in really quick. So that's why we're able to achieve a process monitoring. We're able to do a really quick monitoring on the different sampling gases. As you can see here, once the compound is ionized, it will go through this route, and then the magnetic fields will change the trajectories to make the trajectories hits to our iron compounds. So in here, we are measuring. Let me see. We are measuring nitrogens and oxygens. For the mass of nitrogen is 28 atoms units massed. For oxygens, because it's O2, so it's 16 plus 16, so it's 32. So that 32 is the oxygen's atomic iron mass. So as you can see here, when the magnetic field changed, the iron beam changed their trajectories. So anything that is a mass of 28 will hit our detectors. And after the magnetic field changed, anything that has iron mass of 32 will hit our detectors. So that's the principle. That's the principle of how we operating the mass spectrons. So we are detecting the gas massed, fragments gassed, and then we have a detector to see the signals, and also we convert the signals into our concentrations. As you can see here, some of you guys are coming from the lab backgrounds, or maybe scientist backgrounds. In the markets, there are several different type of mass spectrons. Usually, we'll encounter in the lab. It's called quadruple mass spectrons. So quadruple mass spectron usually come with the GC, MS. They are combining together to become solutions. In our cases, we don't in our process monitors, we are using the magnetic sectors to create a different magnetic field to filter out different the fragments. So in the lab situation, they are using quadruples. That means there are 4 different rods that will change. They will change the magnetic fields, changing from DC to AC to change magnetic fields, and then they select a particular mass, and then let that particular mass of compound will go into our detectors. However, for the process mass spectrons, we want our analyzer to be really durable, really rugged. So the magnetic sectors are most suitable to those applications because it can employ a very high energy beams of ions, and also they have a really deflect by a really strong perpendicular magnetic fields, so that make the instruments much more robust, and then also less maintenance compared to our lab as a quadruple mass spectrons. So here is the detectors. Depends on the situations. and also depends on the applications. Sentinels, they have a different detectors compared to the Prima Pros, and then later I will do the much more explanations to the detectors. So this our mass spectrons Prima Pro is using a Faraday detectors that can go from range from ppm level to 100% level. Since we are monitoring process, not environment, not occupational health, we don't really need that low detection limits on the process. So Faraday detectors are really suitable for our applications. So this is how the Faraday detectors works. As you can see, when the different fragment comes in, they have a resolving slit. That means the detector is able to capture all those ray or all those ions into a sections. So back to what I'm talking about earlier, because the detectors are different, the way that we see in the graph are different a little bit. For the conventional quadrupole MS, you'll see the shape of our spectrums are like this. However, for the magnetic spectrums compared with the Faraday's applications, our spectrums will look like a plateau. You will see a peak and then flat out instead of a round top. So this is why we cause the round top. All those rays will coming in from position A, B, C, D, and E, F. So that's why the peak will not in a flat form, flat currents, flat shape instead of round shape. Okay. So there's another detectors that are using for sentinels. Since sentinels tend to use it at the I'm sorry, tend to use as a, occupational health and safeties. Um, the range can go from PPB levels to PPM levels. So of course, since the magnetic mechanism is a little bit different, the way we do the detection limit will be different. For the mass spectrums, so as you can see here, I was mentioned earlier, this is the common mass spectrum we see out in the gas. As you can see, we have nitrogens, oxygens, argons, and carbon dioxides. All of this, after those gases be ionized, they can break into fragments. N2, the atomic mass units is about 28. When you break apart, it becomes 14. Similar to argon, when argon molecular weight is about 20, but if there's two argons going through the detectors, the molecular will be double, be 40. Oxygen 2, it's O2, we break apart, is 16. For the CO2, the molecular weight is 44. Once you break those CO2 apart, you can become CO, O2, or carbon or carbons. Those are the molecular weights. So we use this molecular weight to differentiate different compounds. See, all those argons, all those molecules have different molecular weights. So, do we measure the complete spectrums? No, we don't, because those compound some molecules or some gases, they might have a similar molecular weight. In that case, we need to figure out what is the most important, what is the most abundant molecular weight when they broke apart. So we cannot measure the whole spectrums from from zero atomic weight to 150 atomic weight. No, so this we have to, when the customer is discussing with you, you have to know what are the gases they want to measure. Are they measuring CO2, O2, argons, or other process gas like methanes, propanes, C2H4, or etc. Okay. So as you can see here, those are the gas this is why the reason we want to figure out what the customers want to measure. As you can, this is a really good example right here. At molecular 28, we have nitrogens, we have carbon monoxide, and then C2H6. All of these compounds right here, the molecular weight is 28. But if we are trying to measure 28, that will create a lot of interference in here. And also right here, you can see C3H8. They do have some chances to break out into molecular weight of 28. So that means we need to simplify the whole numbers to make sure all these compounds, they do have a distinguished molecular weight that does not interfere with other compounds that we want to measure. So as you can see here, for CO, when it break apart, there's a slightly chance they will break down into carbons, which is 12. For nitrogens, there's a slightly chance they will 4.1 chance that will break down into a molecular of 14. That we have the last compound in here to do interference, so we can select 14 for N2. For C2H8, as here at molecular weight 30s, there's a higher chance of this C2H8 to occur at the molecular weight 30s. So that's where we do our index or our targets, the molecular weights for this particular gases. So of course, this comes into concern to your mind. Say, hey, how are we able to do this really quick? And then how do we know at certain compounds that is the CO, that is the N2, and that is the carbon dioxide? We do have really strong softwares that for Prima Pro, Prima BT, and Sentinels. Those softwares are able to do a really quick calculations and also algorithm, so they were able to know as what compounds and what molecular weight is what particular gases that you're looking for. So there's no limit of, so there's no set limits to the number of sample streams. As you can see, our Prima Pro have multiple streams that can come in. So once you set up your methods, that's the gases you want to monitor. The software is automatically calculated at which molecular weight is which compounds. It has a multi-language supporter. Of course, they can do a multi-layout. They can do. We're able to upload the data into customers' control rooms, so they know when they need to change their recipes or introduce more oxygens, argon into their sample streams. Those are the screenshots of our softwares. We have the histograms, anagrams, and also the string status, and also instrument status. So all of this can be reported to the customer sites. They know what's going on with the analyzers, what happened to the sample strings, is any errors that happens. Anything can be set up automatically. We can do an auto calibrations. That means we introduce standards into our systems to let them know this what's the fragments, what are the ratio of the fragments, so they can do a quick conversions from the signals to concentrations. Everything can be exported through Modbus communications. So all of this can be uploaded through customer sites. Multi-language user interface, we do have English, Chinese, Dutch, French, all of this can be changed. So all of this, we do have an interface that we're able to change. Again, there's a status and data reviews. It's a real-time analysis. We're able to report status, concentration, table, and charts, trend charts. All those data can be saved as CSV file. So if the customer want to do further analysis on their trend, they can export it, the CSV, and then import it into their Excel file to do trend analysis. So I will do a really quick. So second, I'll do a quick summaries. So for our mass spectrons, we can do a really quick analysis and multiple strings. We can link up to multiple different strings to do multiple string in sequence. This system was built robust, really sophisticated with the softwares. So there's less maintenance need to do it, less human interactions. Once you set up the methods, they can just run automatically. So I still have about 15 minutes. I'm sure you guys start thinking, okay, so what are something that we're able to implement these instruments into the industries? What are some applications that we might able to sell this mass spectrons, Prima Pro, Prima BT, or Sentinels into customers? So the key away is some industry might need to use our Prima Pro or Sentinel Pro as first petrochemicals, second refineries, third steel or ore manufacturers. What do they need these solutions for? Um, they are doing process monitoring or occupational safety health purpose. So I will start with the Sentinel Pro first. For Sentinels, a lot of time we will place these instruments in our petrochemicals or polymers manufacturers because those industry or those areas they do use a lot of hazardous compounds such as benzenes, ethylene oxide, etc. All those carcinogen can cause threats or cause any occupational health to the workers. Of course, it can cause cancers, it can cause any long-term health effects, and then we don't want this to happen to our workers. So we can place sentinels at one sentinels at one sites where we set up different strings or sampling points at different spots. If there's places that use a lot of organic solvents or any carcinogens, we can place multiple port there to do a continuous monitoring to make sure the workers does not contain exposed to those hazardous chemicals. So as you can see here, for Sentinel Pro, a lot of times they are monitoring benzenes, VCM, EDCs, all those carbon aromatic carbon hydride compounds. As you can see here, those are mainly focused at the petroleum company, refineries, or what's it called? Plastic manufacturers. So as you can see here, something that it's really familiar in Vietnam region is Formosa Industries. So Formosa Industry, the Ningbo, they do use our Sentinel probe to measure ECM and the EDM, those chemical compounds in the atmosphere. Okay. Other than the Sentinel probe, Prima Pro can be a really good applications for the polymer fin, although plastic manufacturers, because the polymers need to have a good right ratio to mix with different compounds and also gas stream to produce the polymers. Applications such as the LDPE, low density polymers, polyethylenes, linear low density polymers, OPP, polypropylenes, all those plastic manufacturers, we're able to implement our Prima Pro or Prima BT to their lab or to their process manufacture sites. So the key components for how Prima Pro is to measure the hydrogens and ethylenes, 1-butane ethylene ratios, and also hexane 1 ratios. For all of this, if the customers at the plastic plastic manufacturers, They are looking for something that is, to optimize their performance, optimize their yield, something this Prima Pro able to in place, and so they can measure the ratios to have a better product or better yield rate. As you can see here, those are the parameters that we're able to do a measurements. Polyethylenes, polypropylenes, those are the compounds that customers are interested in measures. As you can see here, we can do an analysis time really quick, fast in 10 seconds. And then we do have a really low concentration detection limit. So the customers will know what's going on with their recipes, what's going on with their emissions, or also what's going on with their sampling streams. Other than the plastic manufacturer sites, somewhere that Prima Pro able to help the steel work to have a better yield or better products is where the we can place our Prima Pro into their oxygen furnace, or maybe their blast furnace to measure their CO contents, CO2 content, also carbon dioxide contents. So steel companies, they do use a lot of our process manufacturers to measure the different gases, fuel streams, also the emissions from their reactions. As you can see here, I tried to do a quick comparison between different technology compared to our Prima Pro. These gases are usually monitored at the steel manufacturer sites: hydrogen, CO, CO2, oxygen, nitrogen, or argon. The ratios can affect on their quality of their steel. If the customers want to do a low carbon steels that is much they'll have a much better margins, or that's for high sky what's called sky rises. Those are the essential recipes they need to adjust to have a better steel qualities. So as you can see here, our Prima Pro have really good positions. All those positions are at the percentage levels. So that means we really gave out a really stable concentrations. Sorry, the readings. So that means the customer will have a better control or better understanding of their finance or their recipes. So again, as I was mentioned earlier, the Prima Pro is we're able to implement at our coke oven controls, so they can save energies or they can change their combustion ratios. Something like byproduct plants, they're able to monitor different byproduct out of their steel manufacturing process. And also we're able to do is some to monitor hydrogen sulfide analysis, H2S analysis, because sometimes manufacture sites at steel companies, they emit a lot of H2S. We need to comply with the environmental regulations. So the Prima Pro can be installed at their emissions, their stack, their chimney to measure H2S. Other than that, fuel gases, of course, we're able to monitor fuel gases. So we're able to know their mixtures, if they are able to mix with the right gases with their processed gas. So if the customer is looking for fuel gases analysis, Prima Pro can be the solutions to help them to adjust or monitor their ratio to recipes. I'm gonna quick over of what other applications that Prima Pro is able to do. A lot of time, like syngases, customer want to do a synthetic uh, ammonias, or maybe a production of ammonia or methanols using syngas analysis, syngas methods. Then the Prima Pro can comes in as where we can gasify the gas, and then the treatment to monitor the different gases they are mixing to produce their fuel gases, ammonia, or other gas products. As you can see here, ammonia gases, we monitor H2, heliums, CH4, nitrogen, and argons. So those PrimaPro is able to do it since we only measure all this. Sorry, we only measure these 5 compounds. Then we just need to know what their mass, atomic mass is, and then we are able to reconvert into the concentrations. Other gases such as reduction ions, again, this is same parameter as the same gases as ammonias. So of course, we can easily implement these applications into the reduction of ions. Other syngases such as bioethanols, we're able to measure all these parameters. So this is today. Okay, so this is today's presentations. It's going to be a really quick overview of what we're able to do. And then for next few sections, we will have other specialists coming in and talk about the applications and everything that is in the better concepts and better implementation on site. By any chance, do you guys have any questions?
Thank you, Ivan. Do you have any the list of gases and the Prima Pro and Sentinel can measure?
Okay, so it's a little bit tricky because for Prima Pro, as I was mentioned earlier in the presentation, Prima Pro need to
And
know what.
I saw the last slide. You saw that the advantage of the equipment is more precision, more accuracy.
Yes.
Yeah, but do you have the specification of the equipment, the instrument to show
So
the
go ahead, please. Hello? Can you guys hear me? Okay. Mr. Long, so let me come back to you. So for the comparisons, I'll come back to you with the another comparisons, but what need to be measured is something that we need to discuss with the customers. As you can see earlier in the slide, we can measure many different compounds, but we need to know their molecular weight. We do know some typical compounds that we may able to do the measurements. As you can see here, this is really application driven oriented. You can see for ammonia processed, the process we're measuring H2, helium, methane, N2, and argon. So of course we know this is what we need to measure. But so for some cases, the customer need to tell us what are their desired parameters or components they want to measure, because we need to do the study to make sure there's no interference and cause any like a difference between our concentration readings. So back to
so
your
it
question. So back to your questions. Those
so
are
it can measure all the kind of gas, right?
correct, but this is more like a this is more like a application driven solutions. We know works in certain solutions, certain applications. Then we don't really change the recipes. even though we can measure different gases, but we need to understand what are the components, what are the different compounds. It's not like a FTIR, they can do the whole screening, and then we need to pick up the different compounds. This we need to understand if the compounds or components are fragments or ionized, what can it break down into? And then we will go back and then figure it out if this is suitable. But typically, when you look at the application note that we send out for fuel gas, ammonia production, steel work, and plastic manufacturers, they are major similar compounds, and then we already have the recipes. So as you can see here, for Prima Pro at the plastics manufacturer to manufacture polyethylenes or propylene poly. This is the parameters that the customers are usually interested in monitoring. So it's more application driven. So if there's applications, we know this is the components they want to measure.
Okay. And how can it measure the hot gas or dry gas?
Sorry, compared to what?
So as I know, when you measure the hot gas and dry gas, you have to sampling for the gas. You know, if we apply for the CEMS.
Okay, so this is different. This is different than CMS. If you want to do SIMS, that is different applications. This, since we're talking about process monitoring, we are measuring processed. Of course, sometimes we're able to do SIMS monitoring using using the process using our Prima Pro. However, when you talk about SIMS, usually it's NOx, SOx, CO2, and SO2, other similar compounds. We will have different solution for SIMS, but this is more particularly focused on petrochemicals. Um, that's including plastic manufacturers, refineries, fuel cell gas, ammonia manufacturing, etc.
Okay. Can you show me the specification of the Sentinel Pro, Sentinel or Prima Pro?
So you mean certification of what? Hello, hello, Mr. Long. Certification of what kind of certification that you
I mean catalog.
a catalog? Oh yeah, sure. Yes, I can send you the catalog.
I mean the catalog of the instrument.
Yes, we can send you the catalog of the instruments. No problem. Do you guys have any questions regarding the applications?
Anyone have any question?
Sorry, come again. I couldn't hear you.
I think it's okay, man.
One more time. Sorry. One more time. You are kind of far away. The voice wasn't like
Hello，魏先生，你是台湾人吗？
是，我是台湾人。
你可以寄给我那个中文版可以吗？
中文版的 catalog 吗？我看一下好不好？但是因为基本上都是英文的居多。
好的。
Nhân nếu mà Nhân có ở đây thì Nhân có thể hỏi bằng tiếng Trung nhá, Nhân nhá.
Em biết rồi, em nhìn ông biết người Đài rồi.
Đấy thì có thấy có ứng dụng cả trong các nhà máy thép như Formosa đấy, em cần hỏi gì thêm thì hỏi. Như ông ao thì sao?
Như thế ao rồi. Dừng.
Nếu ao rồi thì thôi.
Okay, so Mr. Alonso, if we don't have any further questions, if you guys have any questions, please let me know. Send me an email. We can get back to you, or maybe if there's something that you want to know more regarding the Prima Pro, send it to me. I will have these questions prepared with our application scientists. They were able to help you. They were able to answer the questions for you. For next week, we have our Prima Pro. We have our Tony Guo. It's our application scientist from United States. He were able to do a quick introductions on the Prima Pro in petrochemical industries and ammonia industries. What are the application, what are the compare technology, and also what are the reference that we able to talk to the end users. On Thursdays, we will change our track into themes. I need to change the training agenda a little bit because some engineer wasn't able to do the support next week. So for next week, we have Prima Pro on Tuesday. We will have a particle analyzers on Thursday. Okay.
Thank you, Ivan. So please share me the video of training today.
Sure. Yes. Okay. Thank you very much. Thank you for your time.
Yeah. See you. Yeah.
See you next week. All right. Thank you.
Yeah. See ya.
Thank you. Bye bye.